So after learning about the wonders of empirical and molecular formula, we're now going to use the power of the mole to make some calculations around chemical reactions. This is called stoichiometry. So how do we read equations using moles? So here's an equation. Calcium reacting with sulfuric acid to form calcium sulfate salt, and hydrogen gas is being evolved. So what that reaction is saying is that one amount of calcium reacts with one amount of sulfuric acid to give one amount of calcium sulfate plus one amount of hydrogen gas. We don't usually put in the ones, however, but if we did, it would look like this. Okay, we don't do that usually though. Okay, however, the amount we're talking about in that first sentence is the mole. So now the reaction reads 1 mole of calcium reacts with 1 mole of sulfuric acid to give 1 mole of calcium sulfate and 1 mole of hydrogen gas. And this is the important aspect. So, looking at the equation, if we have 1 mole of calcium, how many moles of sulfuric acid are needed to fully react with the calcium? So think about that. Pause the video now and come back with an answer. Okay, so you should have thought about it and come to the conclusion that it's 1 mole. Next question, if we had half a mole of calcium, how many moles of sulfuric acid will be required? Again, pause the video and then come back when you think you have an answer. Okay, so for half a mole, you'll need half a mole of sulfuric acid, because you've divided it by 2, both sides. Question 3. If half a mole of calcium is reacted with half a mole of sulfuric acid, how many moles of calcium sulfate and how many moles of hydrogen gas are formed? Again, pause the video and then come back when you have an answer. Okay, so the answer is, of course, half a mole of hydrogen gas and half a mole of calcium sulfate. Again, looking at the equation between calcium and sulfuric acid, if half a mole of calcium reacted with half a mole of sulfuric acid, how many moles of calcium sulfate and how many hydrogen gas? Again, we've gone through it, half a mole of each. Given that the molecular or molar atomic mass values of hydrogen is 1, calcium is 40, sulfur is 32, and oxygen is 16, find the molar masses of sulfuric acid, calcium sulfate, and hydrogen. Again, this is kind of going over work we've done already earlier in lessons. So again, pause the video and come back when you think you have an answer. Okay, so the molar masses are essentially the sums of the atomic masses in a molecule. So you can then use these numbers to, and the mole number and formula to work out the mass of the hydrogen gas and mass of calcium sulfate formed. Remembering, of course, that the equation is number of moles equals mass over molar mass. A very important equation. Okay? So, new equation. Iron oxide or rust plus 3 carbon monoxide gives 2 iron and 3 carbon dioxide. So if 200 grams of iron oxide is reacted in the above equation, what is the mass of iron produced? I'm also going to give you the molar mass of iron oxide. It's 160 grams per mole, and the molar mass of iron is 55.85 grams per mole. So pause the video now and then come back when you think you've got the answer. Okay, so welcome back. Hopefully you have an answer. I'm just going to go through it. Okay, so from the equation we can see that for every mole of iron oxide, there is 2 moles of iron formed. There's a 2 in front of the ion. This means that if we can find the number of moles of the iron oxide, we can work out the number of moles of iron and then the mass of the iron that's formed. So the number of moles of iron oxide will equal the mass over the molar mass of iron oxide. Plug in the numbers, so it'll be 200 divided by 160 to give 1.25 moles of iron oxide. Okay, so we have 1.25 moles of that, and we have a ratio So you can work out the number of moles of ion from that. Therefore, it makes sense that using the mole ratio, the equation, how many moles of ion can be formed? Is it known or is it unknown? Think about that. Okay, so it is actually known because you end up with 2.5 moles of iron being formed because it's going to be twice the number of moles of iron oxide. You can use that number now to work out the mass of the ion. So next question is working out how many moles of hydrochloric acid is used to completely react 60 grams of magnesium in the following reaction. So magnesium is reacting with the hydrochloric acid to form salt, magnesium chloride, and hydrogen. So I suggest you draw a grid. One with molar mass, the equation, and the reaction ratio. So pause the video, create a reaction grid as you have on the presentation, and then work through the grid to try and find the answer. Okay, so welcome back. So hopefully you've drawn the grid and you've managed to fill it out to find the answer to work out how many moles of hydrochloric acid is required. So let's go through this. Okay, so you've got the magnesium and the hydrochloric acid. So molar mass of magnesium is 24 grams per mole from the periodic table, and hydrochloric acid is 36.5 grams per mole, also from the periodic table where you added the molar mass of chlorine to the molar mass of hydrogen. Okay, so the mass is 60 grams for magnesium, and we don't know what it is for the hydrochloric acid, so we're going to try and find out. So using the equation, number of moles equals mass over molar mass, we can work out the number of moles of magnesium, which will equal 60 divided by 24, or 2.5 moles. From the ratio, okay, that's magnesium, you can see that the ratio is 1 to 2. So that means that you must need, okay, 5 moles of hydrochloric acid, okay, which will equal 183 grams. And that's your answer. So hopefully you got that right. And hopefully the grid helps you get that right. Okay, so what's the mass of the hydrochloric acid lose? Just focusing on that and how we got that. Okay, so you got the equation, number of moles equals mass over molar mass. So it's going to be, rearranging the equation, the mass will be 5 times the molar mass, because we know we have 5 moles. So it's going to be 5 times 36.5, or 182.5 grams, rounded to 183 grams. So I strongly suggest in exams that you actually use a grid. It nicely sets out the information for the marker, so he knows your train of thought, or she knows your train of thought, and you can see where you make mistakes if you're going back checking, and also the marker can see where you're making mistakes, so he can actually award you for marks, and you can have errors carried forward.